The Retail Trade Association claims that the tax preparation methods of adults, and there are 300 of them, are distributed below. 24% use accountant, 20% by hand, 35% using computer softwares, 6% friend and family, and tax prep services, 15%. And you have the frequency as well. Out of 361 said accountants, 42 by hand, 112 computer, and 29 friend and family, 56 tax prep service. Use alpha equals to 1% to test the claim. So what is the claim here? What is your null hypothesis? What is your alternative hypothesis? So the null hypothesis says the expected distribution of tax prep methods is 24% by accountant, 20% by hand, 35% with computer softwares, 6% family and friend, and finally, 15% by tax prep services. This is our null hypothesis. It is exactly as you see in this table on the left-hand side. And your alternative hypothesis, which is the complement, says, well, not the distribution of tax prep methods is going to be different. So it differs from the expected distribution. Well, what are we going to do? We're going to use chi-square distribution, chi-square goodness of fit. Let us use chi-square goodness of fit test. So what are we going to do? Let's just move this a little bit down here. Chi-square goodness of fit. What do we need? We need to know what is our degrees of freedom. The degrees of freedom is equal to n minus 1. N is the numbers of categories that you have. We have 1, 2, 3, 4, 5 categories. So it is 5 minus 1 or 4. Well, you also need your critical value, since alpha is equal to 1% with degrees of freedom 4, the critical value chi squared sub 0 is going to be 13.277. Now we need to use our table to build the standardized test statistic. Now the chi-square test statistic calculated this way. Chi-squared is equal to the sum of observed values minus expected values to the second power divided by expected values. So how can I find this? I need to form a table and actually write down what are the expected frequencies. Now let us write them down here. We know that we have N 300 participants here, and we also have the percentage for each category. So for the accountant, if this is the method, let's write down the method. For the accountant, the observed frequency, O, or the observed frequency, is equal to 61. The expected frequency is going to be 300 times 24%, which is equal to 72. So one by one, we're going to build E and O and then plug them into this formula. So far, we have chi-squared, which is equal to O minus E, 61 minus 72 to the second power divided by the expected value, which is 72. Remember that this symbol, sigma, represents addition. So we're going to add. The next category is by hand. The observed value is 42. The expected value is 20 times 20% times 300, which is equal to 60. So let us form the second fraction. Here we have the observed value, which is 42, minus the expected value, which is 60, to the second power, divided by the expected value, which is 60, plus the next one. The next category is computer software. The observed value is 112. The expected value is 300 times 35%, which is equal to 105. Very good. So let's form the third fraction. Here we have the observed value, which is 112, minus the expected value, which is 105, to the second divided by 105, plus the next category is friend and family. And as you can see, the observed value is 29, and the expected value is 300 times 6%, which is equal to 18. So now you have 29 minus 18 to the second power divided by 18, plus the last category, which is tax prep services. And as you can see, the observed is 56. And here we have the expected value, which is 300 times 15%, which is 45. So the last fraction is going to be 56 minus 45 to the second divided by 45. So if you add all of these together, you're going to have your chi-squared about 16.958. Well, your 16.958, where is that location? Is this inside the rejection region or not? Or you can compare your chi-squared test statistic with your critical value. Since 16.958 is larger than 13.277, it is inside the rejection region. Chi-squared is in the rejection area. What's the meaning of that? It means that we have to reject the null hypothesis. So we reject the null hypothesis. At 1% level of significance, we reject that the expected distribution is exactly the same as table on the left-hand side.